Alright guys, welcome to my first ever video about chemistry. Today we're going to be working on thermodynamics applied in AP Chemistry. I took AP Chemistry last year and got a 5. Alright, so let's get into some problems. The first one says, which of the following represents an increase in entropy? An increase in entropy means a positive delta S. And I'll make a little chart here to help with phase changes. So a solid to an aqueous to a liquid to a gas. Those are our changes. A solid is the most negative delta S because it has the most order. A solid has the most order because the molecules are held tightly in place. While a gas, on the other hand, the molecules are held very loosely and they flow around freely. So that'd be a positive delta S. And this would be your negative delta S. And in this problem, we're trying to find an increase, so the most positive. Okay, so A, the freezing of water. We know that the freezing of water is a liquid to a solid. And we can just look at our chart over here and see that a liquid to a solid is a negative delta S, which is a decrease. So we know that that cannot be the answer. So we can just cross that one off. B, the boiling of water. A boiling of water in phase change is a liquid to a gas. Now that, on the other hand, you go from a liquid over here to a gas, which means that's a positive delta S, which is an increase, and that is what the question is asking. So we'll put a maybe. Option C, the crystallization of salt from a supersaturated solution. A supersaturated solution is just the aqueous. So if we go from aqueous to a crystal, that would be a solid, which is a negative delta S on the chart. So we know that that cannot be our option. Option D, the reaction 2NO reacts to make N2O2. Now we can see they do give us phase changes, but they're both gas, so we can't use that. But we see that goes 2NO to N2O2. And we can see another way to find out the delta S is the moles. And you can see with the 2NO, there are 2 moles here and 1 mole here. So if you're going from 2 moles to 1 mole, you're getting more ordered. Because if you have more moles, that's more disordered. And then option E has it so 2H2 plus O2 reacts to make 2H2O. And that is 1, 2, 3 moles on the left in the product reactants to 2 moles on the right, which is just a decrease in moles again, which is more order. So we know it can't be either of these options. So we can just go ahead and circle B. Question 2. The enthalpy of vaporization of methanol is 35.3 kilojoules per mole at the boiling point of 64.2 degrees Celsius. Calculate the entropy change for methanol going from a liquid to vapor. The free energy of a phase change equals 0. So this problem, we just use the law of thermodynamics, which is delta G, free energy, equals delta H, enthalpy, minus T, temperature, in Kelvin, times delta S. So in the problem, they told us that the free energy equals 0. Put it 0, and then equals. And then in the problem, it also told us that the enthalpy of vaporization is 35.3. So 35.3 minus T, which is temperature. And they see you give it a temperature right there, but it's in degrees Celsius. It has to be in Kelvin, no matter what. So we have to do the conversion, which is just 64.2 plus 273. No matter what, you always add 273 to the degrees Celsius to find the Kelvin. We see that's 337 37.2 times delta S. And then we would just solve this in our calculators with some simple algebra. So what I would do, I was move the 35.3 on the other side, and then I would divide both sides by negative 337.2. And we end up getting delta S equals 0.104. But here's the main thing you have to remember with this equation. With it equaling 104, that is in kilojoules. Delta S always must be in joules. So we just do a simple conversion. 1 kilojoule for every 10 to the third joules. And we end up getting 104 joules, which is about that. Alright, problem 3. Calculate the standard entropy change for the following reaction. Copper plus 1/2 oxygen reacts to make copper oxide, given delta S values. So first, you would have to find this equation. This is just an equation on the problem sheet, which is the summation of delta S of the products minus the summation of delta S of the reactants. So we take the products, and we would put in 42.63 minus parenthesis. Take one of the reactants, we put 33.15 plus, because it's the summation, 1/2, because we always have to put in the mole ratios, times 205.14. And you would just put that in your calculator, and it'd be a pretty easy problem on a test. So put in 42.3 minus parentheses 33.15 plus 0.5 times 205.14 end parentheses. And you would get negative 93.09. And we can see that's option D. Number 4. In which of the following reactions do you expect to have a decrease in entropy? So this just goes back to what we talked about in the first problem. A decrease in entropy is more order. So option A, we're going from a solid to a liquid. A solid has more order than a liquid because the molecules are held tighter. So we know that that cannot be it, because you have to go towards the solid if you want more order. Just remember that a decrease in entropy is more order. Option B, Fe, iron plus sulfur reacts to make iron sulfide. So we can see that these are all solids, so we have to use the mole ratio technique. So we get Fe plus S reacts to make FeS. We can see that there's 1 mole here, 1 mole here, and 1 mole here. So we're going from 2 moles to 1 mole. So we actually are getting more ordered, but we have to just put a question mark and go through the rest of the options. Option C, 2 iron plus 3/2 oxygen reacts to make Fe2O3. This is just another phase change one. We're going from solid plus gas to solid. You could just cancel the first solid because all that matters is the gas. So if we're going from a gas to a solid, that means a ton of more order. And we can easily cross out B because the phase change has more impact on the order than a mole change. That is just something you have to know. Option D, liquid to gas, we just know that's not right because that's getting more disordered, so that one's pretty obviously not it. And option E, you're going from a liquid to a gas again. Just liquid to gas. That's obviously not it. So we know that it is C. Alright, hope this helped. I'll be back next time to talk about some calculus. I might do some physics. If you guys want that, let me know. Alright, thanks guys.